So thank you for the introduction, and thank you, Olga, for the invitation to this conference. So my talk will not be really on maintenance, because I will focus on 5G network complexity, where you will see that automation is key, and but maintenance will be one of our concerns very soon with these new networks we will try to deploy. So I will first say a few words about the resilience-made challenges we have to face before going to the complexity of the 5G architecture and explaining why automation is key to operate such networks. And beside automation, you can see several meanings, so we'll explain what kind of automation I'm talking about, and to finish by key messages. So the first challenge will be to be able to present all this presentation in 20 minutes. I will try to do my best. So the main challenges and resilience. First of all, I'd like to show you a report from NSA, which is a European organization working on security. Every year they are editing a report based on the outages met by telecommunication operators in Europe. And they are making some statistics, some analytics based on that. So on the left of the slide, you see percentages based on the number of outages, and on the right, mainly based on the hours lost by the customers because of these outages. It's classified per root cause. What is important for me here to see that 56% of the outages were due to system failures, but also 26% because of human errors. So we see, even if we are not talking about 5G yet, that in our networks, in our deployed networks, human errors especially maybe could be avoided by automation. And for system failures, we globally did a lot of analysis of what happened in our networks to improve that first at standard level. So the standards take into account the past failures to the recommendation for 5G. So, for example, here are several examples of the improvement made at the standard level with 5G. I won't go into details because of lack of time, but just to say that they are working on redundancy diversity, they are working on load and overload control. And about overload control, you have to know that the main outages we met in 4G networks were due to what we call signaling storms. And so the overload was not well controlled by the equipment. That's why in certain cases we lost all the network because of first outage in a card, for example. They are working also on service continuity and dynamicity. What is really new is the first one, maybe on the user plane, because what we are able to do now is that from an end-to-end perspective, we are able to build diversity in terms of routes between the smartphones and the destination. It means that even your smartphones could be connected to two antennas at the same time to ensure the reliability. So it's really new. It's not the case today. It will be done maybe use case per use case, but it's a real improvement in terms of end-to-end resilience. Okay, so 5G is learning lessons from the past, but it is not really sufficient to face all these challenges. The first one, I will explain it in detail, is the growing complexity of the networks. 5G networks is introducing new concept, and we will see that even if the resilience has been taken into account in the standards, new complexity is introduced. In the second challenge is what's called the verticals requirements. So by verticals, we mean especially the B2B, so business to business customers that will ask networks to be more resilient than ever. And their requirements are very high in terms of latency, reliability, and availability. For example, today we are close to 5 nines from an end-to-end availability, and the targets for 5G are more around 6 nines, where some some services could ask even 7 nines from an end-to-end perspective. The third one is the interdependencies between critical infrastructures. Of course, telecommunication is already depending on energy networks, as a lot of companies, but the interdependency is working in both ways, because energy networks are basing their supervision on telecommunication networks. So we need to ensure that telecommunication will be ready in case of failure in the energy networks to be able to correct it. In the transport network, it's already the case for supervision as well, but it could be also the case for the next evolution in transport network, like, for example, autonomous trains or autonomous vehicles in a global way. Industry with Industry 4.0 is really relying on what 5G could produce. So these interdependencies are really growing. And the final one is the climate changes. You saw, of course, some natural disasters these last years that were happening in certain areas. So we have to ensure that we will be able to come back to normal state in terms of telecommunication, energy, and so on, very fast in these areas in case of disasters, to help people there. So now to go more in details in the complexity of 5G network. I hope this slide will not frighten you, but the idea is not to go into details, but just to highlight several points of what is introduced with 5G, what is new with 5G. The first new concept is the slicing concept, meaning that we can have kind of private networks depending on the requirements of the services, based on the specific requirements. So I will come back to that. Another new thing is that 5G functions that have been described in the standards and will be deployed soon are it's a result of a split of the of the existing functions before, to have very small functions with services that can be given by these functions. And these functions can be located in core data center, but also at the edge. It is new because compared to now for the 4G, and even closer to the customers. What's new also, it's the multi-access, meaning that we must be able to handle, of course, radio access from 2G to 5G, but also fixed access and Wi-Fi access. And we will have a lot of new devices connected to the networks, not only smartphones, but also vehicles, as I said before, and also globally IoTs, or Internet of Things. What is new also with 5G is that virtualization of the network, of the network functions, is mandatory with 5G. It was not the case before. It was possible to virtualize the network functions, but it was not mandatory. It is with 5G. So it means that we will have to put new layers in our networks to be able to handle that. And for all this stuff, we need to orchestrate the services. So we need service orchestration. We need to orchestrate these network functions to manage them, and we need to orchestrate the underlying infrastructure. All these entities can make decisions in case of outage or in case of, I would say, lack of performance. So we have to decide whether one or the other can make the decision. It's not globally managed. So it's one issue, I would say. And AI would be a really important tool to help us to manage globally the network. And I will go back to that later. So just to say a few words about each concept I mentioned. So about the slicing, what we mean by slicing, it means that for any service, we need a chain of network functions. Some example are given here, but I won't go into details, just to say that some of the functions can be shared between several slicing, can be dedicated to one or the other of the slices, depending on the requirements of each service that will be managed by this slices. So here are some examples saying that, for example, we have enhanced mobile broadband, which is not really, I would say, expecting a lot of quality from the network. Massive IoTs will require specific quality levels, and the more expecting one is the slice 3 about what we call ultra reliable and low latency communication. So for this one, mainly we will need to do dedicate several functions and to locate them closer to the customers. Here is a slide to show you what I said before about the split of functions between of 5G. Don't be afraid, I won't go into detail again. Just to say that for what we call the signaling of the network, it means the control parts. So to be short, we split the network into two parts, the control plane and the user plane. The user plane is handling the data, where the control plane is handling the authentication, the registration to the network, and the mobility. So what we see here is that every function of 5G will offer services to the other functions, and to use this function, the other functions will rely on a bus based on HTTP2 protocol. So we have to manage all these functions, and to go now, this can be in several places, and how it is working inside the data center is an example here. For the core data center, we have several 5G core functions that could be deployed. These functions, as I said before, are virtualized, so they are put into containers. They are software, so it's not physical network functions anymore. It was the case before for 2G to 3G and for the main entities in 4G. So they are based on containers. These containers can be Kubernetes containers, so it's using the cloud to do that. So we see here that for the Kubernetes layer, we have a dedicated infrastructure or organization we have to manage. And under that, we have a real physical infrastructure based on servers at the bottom, on switches, and on routers that can allow to go outside of the data centers to exchange data or to exchange signaling traffic. What I want to show here is that we have to manage all these parts together. That's why it is so complex. And to manage that, we need orchestration. And here's an example on the top right to say that for an orchestration itself, the example here is the ONAP orchestrator, which is an open source solution. We have to take into account several modules, and each of the modules here have to be resilient for sure, and they are relying themselves on containers, so on Kubernetes solution. So we have to maintain that together with the functions themselves. So here is a very quick picture of 5G complexity to show you that it will not be easy to manage all these things as a human being. And of course, automation is key to operate these networks. So what's automation? So automation for us can be based on scripts, on policy rules, but what is really important is artificial intelligence methodologies. So automation is required at a different level. To create a new service first, a new slice. So by translating an intent into a network service, so what is an intent? It means that a customer can ask for a service without knowing what is how it is working technically. So you will just say, okay, I want a video service, I want whatever, a voice service, whatever, and we need to translate this requirement or this intent into a network service to be able to launch it automatically. Then we have to check and complete, if needed, the configuration files. Configuration files mean that to deploy in our networks, we need information from the networks, IP address and things like that. And so these files can depend on the service we want to put in place, on the networks we are, and on the affiliates. Because I didn't say but Orange is deployed in around 30 affiliates in the world, and so it means 30 different networks. So to create a new service, we need also to instantiate the virtualized functions that are required for this size. So that's what I showed before. And we need to connect together these functions to realize the function chain that can represent the service. And to finish, to activate it from an end-to-end perspective, we need to ensure the end-to-end connectivity through the transport network that are between the customer and the edge data center, and between the edge data center and the core data center. So all of this can be done through automation, but it has to be done. It's not done yet. We need also automation to ensure network evolution, because as we are working on softwareized network, we will have to upgrade this network software much sooner than what we do today, because today we can say that when we deploy an equipment, it will stay in the network for several years. It will not be the case with the softwares that can evolve very fast. So we need to ensure that this network evolution will not impact the services and will be transparent to the customers. So the automation is also required for this. When adding a new node, it means that when we need a new more capacity in our networks, we'll add new nodes in the networks, and then for sure it should not impact the rest of the network. To give you an example, a bad example of what happened in France in June, when we added a node in our networks for capacity reasons, it was not for 5G, but for the network in place. We impacted the emergency calls, so it's really sensitive. So we have to take that into account and to ensure that it will be done in the right way. We need automation also to supervise the network. As you saw before in the slide, it's a complex network, so the supervision cannot be done that easily. So to supervise the network and using artificial intelligence, we can use a technique for anomaly detection, for maintenance, could be preventive or predictive, and for root cause analysis. We can also propose what we call the cockpits with assistant for decision head when we don't want that the artificial intelligence tool act themselves in our networks. And we use also automation to validate the new function through functional performance, resilience, security, and end-to-end test. So I'm not exhaustive about where automation is required, but it gives you a global picture. Now to say a few words about which role for artificial intelligence in the management of networks and services. I think we will cross here the many applications you can have in different companies, not only telecommunications, but it's just to highlight what we use. So from information to actuation, so we'll start by observing and describing what the data to be able to characterize what is normal behavior, to be then able, when we know what normal is, to detect anomalies. And it helps also to observe trends and detect context shifts to make decisions after that. To understand and diagnose. So based on the analysis we made, we have to analyze the correlations between KPIs, so key performance indicators, the sensitivity of these KPIs to parameters, and to determine what are the most impacting parameters in this list. It can help also to analyze the root cause of the outage. It can help AI to predict and forecast. So for the network, it could be fine if we could forecast an event like a congestion. And it can also predict spatial distribution of metrics based on geolocalized measurements. And for the final one, the decision and the actuation, it can help in decision making, and to help also on online decision. So we characterize all this level in 3 types: so knowledge creation, decision support, and decision making. To say a few words about AI for networks, so what we do is that we gather information from our networks in raw data, and based on this data, on the business strategy description, on the technical strategy, it means we can have quality of service requirements, quality of experience requirements, service level agreements with the customers, and fault and performance targets. So taking all of that into account, after training and generation, we can have alarm identified by the systems. And based on these alarms, we can decide to make a recommendation or to act directly in the network. So if we act on the network, it can be done by this way. So it's not the case today, even because we worked on this this solution not only for 5G, but what we did for the time being is just the first level of decision and on alarm systems, not the network recommendation actuation yet. But what we'd like to be able to do is that after a decision made on the network, after the action, we have feedback to be able to say, okay, the decision we made before was done at the right level. As I said before, we could have different entities that could make decisions, so we have to choose the right decision, and to ensure that even if decisions are made in different level, they are consistent. So these action feedback are very important to improve the artificial intelligence engine we would like to use in this situation. So here are some example of automation we are working on within Orange. So we are working on what we call policy-based management at orchestration level with policy engine.
I'm very sorry, Bertrand, but we are running out of time. So
okay, so
try to wrap up.
Okay, so I won't go into details. So you see here some example of artificial intelligence where we are working on within Orange. I mentioned this time before. So just as a conclusion, so the key messages is the 5G architecture is very complex and introduces many new technologies. The automation is key to operate these networks, and AI techniques seem to be promising, but the anticipation of these techniques is really challenged because no data are available yet, because 5G is not yet fully deployed. We have deployed some antennas, but the core network will be deployed only after 2023. Even in our labs, we didn't deploy yet the end-to-end 5G chains, so we are not able to get data from that as well. And another key question is where we will do the data collection, because it can be done at 5G level, because in the standards a new function has been normalized, standardized to do data analytics, but also at orchestration level, when we see that in some of the tools like ONAP, there are data collection engine that are in the different modules that are proposed. So it's not decided yet, and this choice can impact the way we'd like to retrieve the data. So thank you for your attention, and sorry for the if I was too long.
Thank you very much. It was a very interesting presentation, and we will